Let's continue our discussion of relations and functions. You saw some discussions of functions in Module 1 and also in Module 2 where you did arithmetic with functions. So let's recall what those words mean to you first before we continue additional discussion. So think about, what does the word relation mean to you? Pause the video here and think about what the word relation means to you. I can say how far a car travels is related to how much gas you have in your gas tank. That's the kind of word relation is when we use it in the English language, and it is exactly the same meaning that it will have in mathematics. So the connection between two or more different quantities can be referred to as a relation. For example, think of the students in your class and their height in inches. We could display these data in a table form or in an ordered pair form or pictorially. Let's say we display them in the table form like you see here. So Robert is 72 inches tall, Sarah is 61 inches tall, and so on. If you look carefully, you have two people who are named Sarah and they are different heights. We can also record our information in ordered pairs. This is called the set notation. A is the collection of all pairs of data that we have here. So Robert is 72 inches, that's the first pair. Sarah, 61 inches is the second, and so on. So we can list them as separate pairs in a set notation in this form. It means that when the input is Robert, height is 72. When the input is Matt, height is 70. So first name Sarah, there are two people with that first name, and one of them is 61 inches tall, the other one is 65 inches tall. So we're saying that the same first name could be associated with different heights. We can also have that two people have different first names but same height. So Max has 72 inches height and Robert has 72 inches height. So they both are 72 inches tall, but they have different first names. The name of the person in this relation is called the input, while the height of that person in the relation is called the output. Well-behaved relations where each input gives a unique output are called functions. So one input giving you one output is called a function. So what do you think? Is this a function? The answer is no, because we have two first names with two different outputs. So same input, but different outputs. So that is why this relation is not a function. And so height is not a function of a person's first name. And that's because two people with the same first name can have different heights. So a function is a relation where every individual input has a unique output. Remember that. Every individual input has a unique output. All right, consider a relation where a person X is the input and that person's sister is the output. Pause the video here and tell us whether this relation is a function or not. Assuming you have come back from the pause, what do you think? Do you think this relation is a function? Well, let's think about it. So if I, Shubhangi, was the person and that's the input, then what would be the output? It would be my sister, which is Anuradha. So my sister would be the output. Now maybe there is somebody else who has two sisters. Since I only have one sister, I'm okay. But another person might have two sisters, and how do you decide which one would be the output? And so clearly you can see this relation would not be a function. And that's because a person can have more than one sister. So you can have multiple outputs. So this relation is not a function. Relations between two sets of real numbers are often given by equation relating to variables like x and y, temperature, and altitude you're at. So there can be many different quantities that are related to each other. When you write it in this form, y equals 3 times x plus 1, x is the input, and y is the output. So each input of a real number x will generate one output, because you're taking that number, multiplying by a 3, and then adding a 1. So this relationship here is a function. In order to distinguish between two functions like y equals 3x plus 1 and y equals x minus 5, how do you know which y you are referring to, this first one or the second one? That is why mathematicians have created a new notation. F is the name of this function, x is the input or the argument, and 3x plus 1 is the output. Here g is the name of the function, x is the input, x minus 5 is the output. So this that goes in here is called input or argument, and this here is called the output. The function names do not have to be single letters. It could be words like temperature or height. So we would read that as f of x equals 3x plus 1, not f times x, but f of x. This reading is very, very important, because that is how your brain is going to interpret what you're reading. So how would you read that? This would be g of x is x minus 5. So the notation, f is the input like we said, x is the argument, and f of x is referred to as the output, or y equals f of x. So when you hear f of x, you should attach that to the y coordinate, and x is the x coordinate. So x coordinate is input, y coordinate is the output if you're looking at y as a function of x. So to understand how this notation works, let's talk about the function f of x equals 3x plus 1. So you can think of it as a machine, where this is an empty spot. Whatever goes in here takes the spot right there, and then that will be your output. So for example, if you want to say the input is x, then the output would be 3x plus 1. What if my input is t? Then 3 times t plus 1 is my output. What if the input is a plus h? Then a plus h. So 3 times a plus h plus 1, that would be my output. You do the next one. Pause the video and tell us what the answer will be. Good. 3 times 1 over 7 square root a minus 1 plus 1. So it does not really matter what the input is. It would just go and take place of this x. And so the collection of all the input x values we have is called the domain of the function. And collection of all the output values of a function is called the range of a function. So domain is all the input, range is all the outputs. Let's take a look at a vertical line test, which will allow you to quickly determine if a given graph is going to be a function or not. So if you look at y equals x squared graph that we've seen before, how do you know if this is a function or not? Remember, one input should produce one output. And so if you have one input getting one output, that means it can only have one y coordinate attached to it on the graph. That's why the vertical line test works. So if you take a vertical line and go across the entire graph, it should only intersect in one point. If it intersects in any more than one point, then the relation would not be a function. So here, y is a function of x. Remember, again, we're looking at y being a function of x. And so since any input produces one output, in every single point on this graph, you have y is a function of x. Let's think about this next graph. What do you think? Is y a function of x? Let's take a look at a vertical line, and what happens? Well, it intersects in 2 points, here and here. And so y is not a function of x. You do the next one. So here's the graph of square root x, And you tell us whether this is going to be a function or not. So again, here is a vertical line. You can see vertical line intersects in only one point, no matter where you are on the graph, and y is a function of x. All right, one-to-one functions. So let's go back just one more. So for example, let's take a look at this function. I said y is a function of x. What if I ask you, is x a function of y? Well, then we would have to look and see if one y input produces one x input, and that's the answer will be what? No, I don't think so, because if you look at one y input, you can have this one or this one as the output. So x would not be a function of y, but y is a function of x. So if you reverse the roles of x and y, does it become a function? That's the question we're looking for when we look at one-to-one functions. So in other words, a function that is one-to-one, each output has only one input. Such a function is called one-to-one. So that means we can look at horizontal line test. I probably hinted at that when we looked at the x-squared graph. So let's take a look. Here's our graph. Let's take a look at a horizontal line. So you can see that one output produces one input. And so here y is a function of x, as we saw in the previous slides. And now x is a function of y as well. Or the function is one-to-one because one output produces one input. So this function is one-to-one, as you can see, because of the horizontal line test. So y is a one-to-one function of x, which would allow us to look at the reverse function x as a function of y. All right, let's take a look at this graph. As we saw before, look, this horizontal line intersects it in a point here and a point here. So this function would not be a one-to-one function. Okay, how about that graph? This is y equals x cubed. Well, let's take a horizontal line and take a look. Sure, it looks like this is a one-to-one function. So here y is a one-to-one function. All right, so to check algebraically, in case you don't have a graph, what does that mean? Function is one-to-one, then what do we want to make sure? We want to make sure that the outputs of a function are equal only when the inputs are equal. So one output should only have one input. One output cannot have two inputs, then it would no longer be a one-to-one function.